Okay, so I give it. You've got to give it a good old bung. Much better giving it a good old bung than just letting it leak out of your hand. All right then. So when you're ready, and take a sort of a run up, you know, and then like you give it yeah. Okay then. Right then. So filming.
Yep.
When you're ready.
What changes have you made to the plane since its unfortunate landing?
Well, we've dried it off.
That's a good step. Can you describe the flight?
After launching, the elevators weren't properly working. So it didn't really have much control and enough power to get going. So it fell out the sky into a wet field.
Oh, that's not good at all.
No, especially since it's made out of cardboard.
Yeah.
A little bit turbulent, but it feels quite stable. How'd that go?
Okay, until it got soggy.
Well, it looked like it flew.
Yeah.
Yeah, but it came out of the sky in the end. Well, why might that have been the case?
These basically got so soggy that they tore.
Yeah.
And caused the plane to turn in.
Yes, no, I think you're right. Look at that. So the first landing got it all wet, didn't it?
Yeah.
So what will you do to avoid that in future?
Cover with tape.
So could you hide all this stuff inside the plane next time?
I think so, yeah.
Yeah. So the question is, does the concept fly?
Yes.
So what's the next step?
Build it in full scale using foam board, and obviously the foam board's waterproof, but we might put tape on.
Yeah, sounds a good idea. Right, it doesn't like speed. It's quite happy at low speed. Yes, it's quite smooth. Okay, this is what we've had in the past. So we tend to find the canards fly really nice slowly, but when you pick the speed up, they really go unstable. And I don't quite know why. I think it's mainly because the canard plane is too large or something like that. But if we wind the speed up, what we'll find is it becomes a little bit pitchy, like that. It's suddenly stuck its nose down. Nothing I can do about that. Let's get more speed up. Okay, oh, look at that. You see how it just stuck its nose down?
Yeah.
Okay, I don't know how to counter that. In the design, I don't know what that is, why that does that. Obviously the wind gets the wrong side of it, and then it's a massive great surface to push the nose down. So canards fly really nice and slowly. That's a lovely plane, isn't it? And look at it, it's flying pitched very level. So very comfortable if you're a passenger. But it's what happens when that speed gets up. Let's get it up a bit higher. Okay, let's put a bit of speed on. So it's very pitchy. Wow! Look at those clouds. So, maybe a bit of research. Let's fly it in and land it nicely so we've got a plane to take home with us. And work on what we've got to do with the proportions of that canard. See if I can land it. Because we've got no rudder, of course.
Could be that the canard is still too big.
Yeah, quite possibly. Okay, what have we done?
I've taken 2 centimetres off either side of the canard, and I've moved the centre of gravity about half an inch.
Okay, so that will require us pitching this in positive pitch
A little bit, yeah.
for the whole
you're
flight.
getting less lift and more nose weight.
So my thinking is, I mean, I don't know this, but because that's neutral, if it flips from one to the other, it becomes unstable. Whereas if that is in constant pitch, if you can just activate the plane.
Is the transmitter on?
Oh, that's a good idea, yeah. Right, so if that's in positive pitch,
Yeah.
it's less likely at speed to suddenly flip the other way.
Because it won't be catching, it won't be like a
Yes, that's right.
as such.
Okay, let's give that a go. Let's take it out.
That's actually a really fair point, that.
Okay.
Yep.
Oh, it's doing it again. Not so much though. It is just. Yeah, that's much more stable actually.
So it's probably the fact that the canard was just
The canard was too big. All right, but oh no. Ow. It doesn't like speed. We're all right floating about, but it just doesn't like speed.
Maybe it is that the canard. As you said,
It's an unstable format.
the canard have
You've
a
got,
pitch, but
you've got very little behind the plane, keeping everything in line. So it's an accident waiting to happen, really, a canard at speed. Anyway,
yeah.
speed it up. Well, is that faster than the other one? I think it is. Oh, downhill run. All right, bringing it in.
But it's like a happy die.
Can you go grab it? So, cookies. That's alright. Oh yeah.
Oh, good. That's a result. With speed.
Yeah, pitches down, which is not ideal, but
It's catastrophic.
Try reducing canard.
I mean, as a solution for speed, it's a non-starter, isn't it? I mean, it flew beautifully, didn't it?
Yeah.
Slowly.
if we can fix that issue, then it would be brilliant. It's good at carrying.
It would be more stable if it was the other way around. If it was a conventional plane, it would be more stable.
It's quicker. It's a pusher as well.
Well, you've got to
so
prove
that
it.
helps.
So what you want to do is we'll get the GPS on it and then compare it with one of the other planes you made from last year.
They're gone, I've lost it.
What's the plane called?
The Boulder Mark II.
Mark II. What changes you made to it?
Quite literally everything is different.
Okay. So you've got a longer fuselage.
longer
And
fuselage,
you've got
different wing.
It's like a Versa wing, yeah.
Yeah, different motor. First one was not an